OK, thank you all for coming. I'm here to talk about layered APIs. This is a technology that I've been working on for a while. Ojan queued it up for us really well in the keynote yesterday, kind of explaining how this is a big piece of our overall effort to make the web easier to use for developers and allow them to create good experiences without savant-level knowledge of the platform, without pulling in tons of JavaScript libraries, without having to really get at that level of mess, essentially. One thing to note up front is that some of you may have previously heard of this topic under the name permafills. They're not called that anymore, so don't be confused, because I'm going to say layered APIs a lot. All right, what are layered APIs in general? So the basic idea is that we want to add a lot of new high-level features to the web platform. We've been spending a lot of time over the last few years saying that we should add low-level features, we should add new capabilities, we should allow web developers to build up whatever they want on top of these. But this has led us into a world that is suboptimal in many ways. Right? You can build a lot of things on the web these days, but to do so, you need to understand very complex APIs. You need to pull in large libraries that wrap those APIs into something higher level that you can use. It's a pretty difficult world we've placed ourselves in. Now, in the past, efforts at building high-level APIs have not gone so well for a variety of reasons. Essentially, we say that it's just a process that hasn't scaled well in the standard space. But we think, with a few interesting technical choices, we've come upon a solution that should make it better, make this time better. And so in particular, for layered APIs, we've said that you have to opt into them by importing a module. So they're built on top of JavaScript modules, and you import them instead of automatically getting them included in the page. This is important because if we want to have a bunch of these APIs, we don't want to just be adding to every page's context and startup time and memory usage. We want to say, pay for what you use. If you want something high level that works for you, use it. If some other site doesn't need it, they don't need to pay for it. Another thing is that web developers have historically not had a lot of incentive to adopt high-level APIs when low-level APIs already exist, right? So let's say you can write a bunch of code that uses the low-level API and it works in all the browsers. Or one browser has shipped a nice high-level version, and you could write your code against that, and now it only works in that browser. Pretty much all web developers are going to choose the verbose code that works in all the browsers, that uses the low-level API. So what we've done with layered APIs is we said we want to build in the ability to fall back to a polyfill so that developers are encouraged to code against the high-level API, write much smaller amounts of code, and only in browsers that need that polyfill do they pay for the backfilling on those capabilities. Finally, we said that when we build high-level APIs this time, we're going to maintain a really strong engineering discipline that they're always layered on top of existing platform primitives. So they always use APIs that we already expose to the web. They don't do any magic that web developers cannot already do. And this is really important because it means that we're never locking up some new capability, some new thing that a web developer wants to do behind this high-level API, which may not perfectly fit their needs. If at some point they're like, this API, this is not cutting it for me, they can fall back to the underlying low-level primitives, which you've already exposed, and get all the power they need. And we have a really good example of this in Async Localstorage, which I'll talk about in a bit. So if you want more info on the general project and the motivations, please check out these links I put here. You can go through the central slide link, but this is the general idea. To convince you a bit more as to why high-level features are important, we can go back to the original Extensible Web Manifesto. This is many years ago. We released, this is kind of a new idea at the time, that we should be focusing on building low-level primitives into the browser to enable developers. But people often forget the second half of the manifesto, which is after developers have figured out how to use these low-level primitives, we should then come back and say, OK, let's codify the patterns that you've chosen into the platform and allow you to just use them without thinking about it, without going and searching through NPM to find the very best library to do X, right? And of course, this helps us solve the problem that we hear more and more about every day, which is that web apps are too big. They're pulling in too much code. We want to make it possible for you to code a web app out of the box with less code. And this, in a big way, this is just kind of making the web competitive with native ecosystems and just computing platforms in general. If you write an app in iOS, for example, or Android, you can just go to your controls toolbox and pull out a bunch of very useful things. Or you can go to the standard library and pull out a bunch of very useful tools. On the web today, you have to comb through a bunch of search results saying, OK, what's the best way of doing key value store? What's the best way of doing an infinite list? What's the best way of doing a carousel? And every page uses a different version. Some of them may be coded poorly, not taking advantage of the latest browser features. In the end, to get a good version of all of these different high-level things, you have to have, as Ojan said, savant-level knowledge of the platform. It's really hard to build web apps right, both for yourself and to give a good user experience. So the idea of adding more high-level features is we want to give the web the standard library that it really deserves. To make this more concrete, here are some examples of what we think of as high-level features. And I've kind of divided them into two buckets, roughly. One is more library features on the left, things like an async key value pair or a better date time library. These are all things you could build today and that people have. And in fact, people have built it so many times that we kind of know exactly what they should look like. But they still have to pull in many kilobytes of JavaScript to get these capabilities. Similarly, on the right, I have a collection of kind of UI controls that are just commonplace in every other UI platform. But on the web, you have to build these yourself. And so you have to first figure out, am I going to use React or Ember or jQuery or whatever? And then you have to find some control that works within those. And there's just no common vocabulary to figure out how you're going to do basic things. So we want to enable the web to have these things out of the box for developers, but again, in a scalable way, so they only pay for what they need. And if they need to, they can drop down to the low level. Concretely, how do you use layered APIs or LAPIs, right? So as I said, you import them as a module. And here I've shown the import syntax, or the fallback syntax. So you say, I want to import the std virtual list component, the module. But if it's not available in this browser, I want to fall back to this URL on some CDN. So we're hoping this will make it really ergonomic for developers to say, I'm going to use the virtual list. I don't care if the browser has it. If they don't, I'll download some extra code. But I'm just going to code against this standardized API, and it'll work great for all of my users, right? You can use this also inside of modules themselves. Here's another example more along the lines of a library, where you have async localstorage is one of the LAPIs we're considering. And so you just import that, and you can start using it straight away. So another cool thing about LAPIs, and this is more on the Blink side, is that we, at least, are planning to implement them in JavaScript. Now, these are standardized features. They have a spec. You can implement them however you want. But because of the choices we made in setting them up in designing LAPIs, it's possible to implement them in JavaScript, right? We set a constraint that there's nothing you can do. You're not allowed to have anything in a LAPI spec that a JavaScript developer couldn't already do. And so in Blink, we're going to do that. And this has a few benefits. One, it makes sure that we never cross that line. We validate that the spec has never crossed the line into doing something inaccessible to web developers. And we actually discovered a few interesting examples of this that I'll talk about later. Another big one is that other engines could use our LAPI implementations if they wanted, or they might have to do some work to adapt them to their architecture. If ours uses resize observer and they have an implemented resize observer, then they might need to either implement it or add a little bit of magic on their side. But we're hopeful that this will have a lot of velocity impact across the web ecosystem in spreading LAPIs. So even if it's not the highest priority for some other browser, which may be more behind on the low-level features to add these high-level things, it's still really easy for them to do so. And hopefully, they'll just do it. And then, of course, just as an implementation benefit, it's much easier to get that kind of lazy-loaded pay-when-you-import architecture if we reuse the infrastructure we already have for loading JavaScript scripts, right? We could try and invent some way of dynamically, well, not invent necessarily, but we could try and dynamically load DLLs full of implementation code for these high-level components. But that's much harder than just using what we already have in place for JavaScript modules. All right, so that's the general idea. That is layered APIs. I want to tell you first about where we are, what we've been doing, and what we're kind of on track to do this quarter, and then end with some interesting open questions and things that have come up in the process to kind of spur some discussion. OK, so the first thing to note is that we've figured out what we're doing, right? So as I mentioned earlier briefly, you may have heard this called by the name permafills. That was a terrible, misleading name that really gave the wrong impression about what we were trying to do. We're not baking libraries into the platform. We're actually standardizing features in the normal way through the web standards process. And we just have these extra constraints. We briefly dallied with the name layered web APIs, but LWAPIs is not pronounceable, so not that. As I said, we at first started out saying, yeah, we're going to just write a bunch of JavaScript libraries and put them in the browser, and that was the focus. But that messaging turns out to be too restrictive on what implementers want the freedom to do, and pretty confusing for web developers. So really, as I've been trying to say, this is a new standards effort for high-level features, and the fact that we're going to implement them in JavaScript is an implementation detail of Blink that will hopefully have some knock-on benefits. But it's not a requirement of how you do LAPIs. The other thing is that for now, we've settled on that fallback syntax I showed you, the std x bar y. We just want to get something out there behind a flag for people to play with and see how it feels. And so we're gonna do that for now. There's been a lot of discussion, and it's still I listed as one of the open issues. But that's kind of in the overall LAPIs infrastructure, things have settled down. There's kind of 4 main projects that we've been focusing on as a team, and lists here. I want to go through each of them briefly in turn. As I said, so LAPIs loading infrastructure is largely about this new kind of URL syntax. It's actually a module specifier syntax, so it's not, you can't fetch these independently. You can only use them when loading modules. But there's actually a lot of precedent for that on the platform with things like media blob URLs and so on. We had a lot of alternatives. There's a lot of discussion about, how should this fallback work? Like what characteristics should it have? So in particular, one interesting question is, should this work? Should we be able to fall back to polyfills in browsers that don't support LAPIs at all? So this syntax that we settled on for now doesn't allow that. But you can imagine versions where, like, maybe if the browser supports modules but not LAPIs, they'll still get the polyfill. So we're just going to prototype what we have here and get web developer feedback and try and make this a little bit more real, see what other implementers think. And I'm pretty excited. So shout out to Hiroshige for his work there. All right. Our first LAPI that's really kind of furthest along is Async Localstorage. I'm really excited about this just because the number of web developers who flip tables over the fact that we don't have a reasonable key value store on the web is just enormous. Like you tell them to use IndexedDB, and they're just like, why do you hate me? It's unfortunate. And then they just go back to using synchronous local storage and janking their pages. And this is just one of those things that makes the web terrible. So we just should add something that works. That's an asynchronous key value store that you can actually use for 80% of your storage needs without janking your pages. So since it's a layered API, it's layered on top of something. It's we're not going to do any direct talking to SQLite or LevelDB. We're layering this on top of index database. And this is pretty cool because this actually means that if you're using a key value store, but one day you're like, oh, I need transactions, you can just say, oh, well, I'm just going to use the IndexedDB API on my pre-established storage area, and there we go. So I think that's like kind of a pretty stark example of the benefits of this layered philosophy. So we have a spec. It's pretty complete. We're starting to shop it around to other browser vendors, to developers, and get feedback. We've been getting a lot of good feedback. It's an interesting spec because there's a lot of unusual verbiage around, call this IndexedDB method, basically, like, perform the steps involved in indexedb.open. And that's an unusual style, but I think it's been working pretty well so far. In the course of writing it, we discovered some missing primitives, and I'll get to those soon. But I think it was a really good exercise, and it's encouraging for this effort. So our plans for this quarter is to implement async local storage behind a flag, write a bunch of web platform tests for it, and put this in web developers' hands. So I'm excited. The other big hero lappy that we're trying to come up with out of the gate is a virtual list component, right? So if you're trying to write an app, you follow any tutorial on the web, and it's like, oh, look, hello world. And like, oh, you click this button, and you get an alert. But you follow a tutorial on like iOS and Android, and it's like, oh, hey, look, let's build a Twitter client. And like, you just use UI table view, and like, boom, it's done. On the web, we have no such thing. If you want to create a performant list that virtualizes its contents, you have to first pick a framework, and then you have to go search for the best virtual list in that framework, and then you have to notice that they're not using resize observer or intersection observer, so it's a terrible choice, and you should go write your own because nobody's doing it right. We want to just have these high-level abilities like a virtual list out of the box. So we spent a bunch of time trying to get this right. This is a pretty complex area. We studied so far 4 implementations across different ecosystems. iOS's UI table view, WinJS from back in the day, Windows 8, and a few others. And we kind of figured out what is an infinite list at its core. What are the core use cases and requirements? What are the bells and whistles, headers and stuff like that people want? And we've got something that we're pretty happy with. So Valdrin is prototyping the infinite list element. It's under very rapid development. I still have some pull requests out to review on some changes to the public API. Another cool thing about it is that he's built it out of several interesting smaller pieces, like a virtual repeater and several other pieces that all compose together to give this high-level, several kind of mid-level pieces that compose together to give this high-level virtual list element. And we may expose those later. For now, we're going to, for V1, just expose the public virtual list element. Another fun thing about this, and I really encourage you to check out these slides and click on the demos link if you can, is some of these demos that we've put together. So for example, we have a demo that loads the single-page HTML spec as a virtual list of all of its top-level elements. And this is really neat, because if you've ever tried to load that thing, it takes 5 to 10 seconds to get all its content into Chrome. And whereas if you put it in this virtual list, it's like, boom, it's ready to go. And as you scroll, more stuff loads. That's a pretty novel use case for a virtual list, but it works really well. In the course of doing this, we discovered a few things that are missing. If we really want a first-class virtual list experience, that not just one that's as good as you can do today, but something that's kind of the full potential of the web, we want to be able to make find and page work. If you search for something and it's currently being virtualized, we want to make sure that we can still scroll to it, still find it. Similarly, if you're a search engine, you really, right now, you only look at the contents of the DOM. But if you've got a bunch of information inside of a virtual list, how do we expose that to search engines and other indexers? And finally, if you click on a link that goes to some part of the DOM that's currently being virtualized, how do you scroll to that and make sure that displays in the list? So these are all interesting problems to explore, and we think we have some tentative ideas towards a solution, but these aren't really blocking, I think, V1 of infinite lists that we could get out there. Anyway, this quarter, we're going to get something that's pretty finalized on the API surface that has a comprehensive explainer and kind of description of how everything should go. And we want to reach out to other vendors and web developers and kind of the usual parts of the standards process to get this rolling. So this is an ambitious effort, but I'm really excited because I think this just really shows the value of shipping high-level features. Finally, in terms of lappies that we're working on, we have a mystery third lappy. It's on my quarterly goals. I gotta figure out a third lappy. I think the more we can do, the better. The more it shows the value proposition. And currently, we're thinking let's do something in the UI area. We have a lot of data that from different UI frameworks like jQuery UI or AMP or so on, that saying what are the most commonly used controls. And some of these come up as often used. So we might try and build something like this in the browser so not everybody has to build their own every time. But your suggestions are also welcome as to what the mystery third lappy should be. Haven't really started yet. OK. Yeah, to close up, I just want to give a few interesting issues that have come up and kind of a status on where we are with those. Some of them are pretty technical, some of them are bigger picture. But let's start with a pretty technical one, because I think it's illustrative of the kind of problems we've encountered. So an interesting thing about implementing APIs in JavaScript is that anybody can read your source code, because we have this wonderful feature in JavaScript called function.toString that you can call and read the source code of any implementation. So when we implement our APIs in the web browser in C++, even though they're exposed as JavaScript objects, we censor their source code. Right? We don't expose the C++ source code, of course. It just says native code. We would kind of like to have that same encapsulation, that same ability to change our source code without people perhaps starting to depend on it or whatever for lappies. But we have this ironclad contract. We're not going to do anything that web devs can't already do. We're not going to use any magic like censoring source code that web devs can't. So we're just going to let web devs do that. We have a proposal in TS39 to allow web devs to censor function toString. It's a little thing, but I think it's kind of like, why isn't this already there? Why have we restricted this to the browser? And this also has some nice knock-on benefits for memory usage and things like that. If you look at graphs of the memory usage on, for example, mobile Twitter, the single biggest category is in source strings. So that could be pretty nice as well. Another kind of more low-level, but more tricky thing that browsers do that web devs don't have access to is that they always call like the original algorithms for a given capability. So if they want to append an element to the DOM, but somebody's overridden node.prototype.append child, they can still append things to the DOM. They don't get disturbed by that. If you're a web developer, you actually don't have that ability. You have no ability to call the original algorithms for something. So we think we should provide some way of doing this. And here I have a link that you can follow up on to see the proposal we have for this. It's not super ergonomic, but I think it'll work. And again, I think it's really nice to say that web developers should have this ability, which right now we've just reserved for the browser, to write robust code that doesn't get tampered with by other code on the page. We've had some talks with V8 and bindings folks, and probably want to have some more before I fly back out. Moving on to a couple higher level things. As I said, the fallback syntax is still a little unclear. We're going to prototype it. We're going to see what people think. But here are some issues, right? So as I said, it won't work in browsers that don't implement this fallback syntax at all, right? They have, even if they, so once they implement this fallback syntax, then they can get the fallback to the polyfill. But if they don't implement this at all, then the polyfill won't load at all. So that's not great. But maybe it's OK because all the browsers are evergreen, and we have a lower bound of compatibility on modules anyway, so we're not sure. Another weird thing is that because we write the fallback alongside the import statement, if you import, say, local storage, async local storage, multiple times in your app, you could end up with multiple fallbacks. Now, if the browser doesn't implement async local storage, does that mean you get 2 different polyfills for async local storage in your app? That could be bad. We could pick the first one, but then it's like you're importing something that you never actually asked for when in the second import statement. We're not sure. Finally, it's really long to type. All my examples wrapped to 2 lines, and I'm a little sad about that. So we have an interesting alternative in this kind of separate project, which we're going to have a brainstorming session on later on package name maps. That's like a general proposal for making JavaScript modules more ergonomic. But I think that could have some applicability here, depending on how we tweak it. But yeah, we'll see. And then finally, what other lappies should we prioritize is another big question going forward. So we have that backlog of ideas I showed you on that slide, kind of a bunch of them. But we just need to apply the usual techniques. What do web developers want? What are popular patterns that we've already seen a bunch of in libraries that we're just seeing downloaded a bunch? What do other vendors think is just something they've really heard over and over as a big pain point? One thing I want to do at BlinkOn especially is ask you all, right? So we've had a really good relationship with the storage team where they've heard from years, or for years from web developers, that it would be really nice to have a normal asynchronous key value store, and so we're layering that on top of IndexedDB, which they maintain. But does your team work on some low-level thing that is really powerful, but to do the 80% case requires a bunch of code and is pretty painful? Maybe we should work together on a Lappy for that type of area. So please talk to me if so. All right, that's Lappies. I hope you're as excited as I am. I think this will make a really big difference to web developers, and yeah, I think it's the start of something. Yeah, it sounds like we have time for questions. I don't know if people are interested, but
hello.
Oh, hi.
It's more of a comment than a question. So for the virtual list case, I just want to highlight how important is the finding page. We use virtual list in Chrome's own UI, like in settings and other places like history downloads. And the #1 thing we get for accessibility reasons is that I hit Control F and I don't find it, but if I scroll, I find it. So that's one. The other one is keyboard accessibility, like hitting tab and getting to the hidden nodes or page up, page down, etc. These are the things we've hit. For the record, we use Iron List from Polymer. Yeah. It was just one of the many implementations of virtual lists.
Yeah.
And then just one suggestion for your mystery Lappy.
Yeah.
I know there's already discussion about potentially adding this into the web in GitHub, but maybe add event listener API that actually returns an ID. So when you remove, you don't need to kind of remember that you're passing the wrong function that was bound or not bound, etc. I don't know if that qualifies, like modifying an existing element. Is that qualifies for a Lappy? Just an idea.
Yeah, those are several great points there. Just the ones that I want to respond to. Accessibility on virtual lists is a great example of something where the reason to build a Lappy is because a lot of web devs do it wrong, right? A bunch of those things we list, like, yeah, maybe they're not too complex to do if you want to do the simple case. But if you want to support accessibility, if you want to support a bunch of different, kind of the use cases that form the long tail of our user base, you really want something that has a lot of thought put into it. And I think that's where we can add value. And yeah, secondly, currently we're trying not to modify any built-in APIs. We think that's a step too far, at least this early. But it's definitely something we're thinking about. Like, how can we add on to existing APIs to give them more high-level features without monkey patching the prototype seems kind of weird. Cool.
Hi. So it looks like outside of Blink, there's an expectation that you could implement one of these in C++ as a built-in and not directly call the underlying platform. Is there a risk that another browser implements a Lappy without implementing the low-level interface? They just go, oh, we don't need this because we have the Lappy. And the Lappy actually ends up becoming the only cross-platform way to access a thing. And the follow-up question is that a problem? Or is it just like, well, we created a better API?
Yeah, no, that's a good question. I do think it's a little problem, a bit of a problem. I think it's not as much of a problem if, as it would be if no browser implemented the lower level API. I think all that would do, or I think in an ideal world, what that would do is put pressure on other browsers to say like, hey, people are currently indirecting through this like magic that you've created, this high-level API to get at this low-level capability. This is really a sign that you should prioritize that low-level capability. And hey, like people over coding against Chrome are able to use it directly. So I think it's a balance in market forces there. Like we definitely don't want to say that Lappies can only build on top of things that are shipped in every browser, but we do want them to build on top of the web platform to whatever extent we can define that. Cool.
You got time for one more question?
Yeah, seems like.
Why not just write the specs in JavaScript and say it doesn't have to use this, but it has to have the same behavior as the JavaScript?
Yeah, we thought about that. And actually, there's a small part of the spec that I did write in JavaScript because I thought it was much simpler than writing out all the details. There's a few things that, some of it's just kind of social. I think people are used to seeing specs in English, and that kind of gives more of an impression that you get to choose how you implement it. And I definitely want to say, like, you're allowed to implement this however you want, even if they could translate mentally from JavaScript to C++. The other is that idiomatic JavaScript for a lot of these things is kind of hard. So for example, calling the original built-ins, if you actually wrote that in JavaScript, it would be pretty obfuscated JavaScript. So we want to have that still, but writing it in spec keys is easier. Similarly, like private symbols, or private fields, that'll get easier in later with the in JavaScript directly with the shipping of private class fields. But for now, you'd have to use weak maps, and that would be a very obfuscated spec. So that's the idea.
Thank you.
Cool.
One
Again.
question. So this one is for the importing the LAPI or the polyfill.
Yeah.
I understand that from the slides there's already a lot of discussion on the syntax and some of the downsides. I'm just trying to think if can LAPIs depend on other LAPIs, and if that's the case, how do we end up with declaring kind of like an packages.json file? Like if I want to say if all those things are missing, I want you to grab them from there. It seems like there's no dependencies in this syntax, and maybe that needs to be fleshed out a little bit more of whether once we have a LAPI, is that considered a low-level API that other LAPIs can be based on?
Yeah, that's a great question. I think there's a number of solutions. Like, certainly if we centralized everything so that you only had one mapping from a LAPI to the polyfill, then maybe it would make sense to say that a LAPI could depend on the polyfill mapped version. But you could also just say they're allowed to depend on each other, and if you haven't implemented the dependency, well, you better do that if you're going to implement the second LAPI. I don't know. It's worth thinking about. But yeah, good additional bullet point for our kind of discussions there. Thanks.
So the who will implement the fallback implementation, and the fallback implementation could be very messy because there are subtle differences between the browser implementation. What do you think about that? Yep.
So we've seen a lot of enthusiasm from the community in polyfilling in general, and we're hopeful that we can tap into that in LAPIs as well. And these are people that kind of thrive on just making their stuff work, even in messy situations with lots of browsers. I think we may try and jumpstart this at first. For example, I think it's going to be pretty easy to put together an async local storage polyfill, and so we might put something up. I don't know if we'll put it on a CDN. We haven't really talked with the CDN folks at Google or anywhere else, but we can kind of try and help there, and yeah, we'll see how it goes. Cool. Okay, I think we're done here. Thanks so much, everybody.